lecture. Road projection stakes is Philip Beutel's topic, but my topic now should pop up. Philip, you're finished. Here we are. So my topic today is distraction potential for other traffic participants. And I did this together with Jonas Kopper and Christian Hinterwelde. My lecture will cover several topics. First of all, I want to talk about digital projections and research, safety benefits. All this, what we have to look together, why do we do it? Now the next discussion pops up because this is the usual standard. Distraction, why can't we do this? Is it bad? Does it mean any harm? Does it is somewhat distractive or produces accidents? And for this, I will present to you a test setup that we did and some luminance measurements, crazy ideas, crazy results, I can tell you. And therefore, we developed a kind of readability area, and I will then end with an analysis and a summary of that. Now, coming to the safety benefits or digital road projections and all, this is a serious solution which is on the road. That is one of these orientation lights which gives you an orientation on your road. You see the camera discovers these yellow lines and keeps this light carpet within the yellow lines. And inside of this, you see some chevrons. These chevrons indicate the position of the car in that area. So this is a digital projection, which is perhaps not so bad. There are other things which are in discussion in the regulatory world, and these are the symbols that are in discussion, and in fact, it's only 3. Everybody asks, why are they 3? Perhaps it's some concerns that if you make many, they may be distractive or anything like this, and we will cover this in this lecture. So there are discussions about snowflakes, to talk about the warning of cold or freezy roads. We're talking about general warning symbols, and we are talking about an accident warning. Look, there is some accidents ahead. So these are the symbols and the projections where we talk about digital projections. As Philip was saying, this is outside of the car. The information, mostly for the driver, not for the others, but they might be distracted. Now, the research on the benefits was also done. There were many researches I put out for the guiding lines. The investigation of the Karlsruhe Institute for Technology, where they made some investigations about the guiding lines, which you see here, which show the steering wheel velocity, if you have such guiding lines, reduces about 60%. The steering wheel motion reduces about 34%, so you keep your lane better. Well, good result. Another study was done by Elo Rosenhan, his colleague from Automotive Lighting. The lane keeping ability, if you have such indicators, are you able to keep the lane? Yes. The safe center corridor is less, let's say, lost by 20%. And another study that I conducted with Audi, that we said we are making an overtaking in the construction zone. That means we have one vehicle, a limited narrow lane, and you have the task to take over. What do you do if you have these indicator lines or not? And you see, if you have these indicator lines, the gas throttle position changes not so often. So it means the people keep more stability when overtaking. The steering angle frequency changes not so much as you do without, because you have a clear indication. So in summary, all good results from these 3 benefits, 3 researches, and 95% positive ratings. The people like it. Now, we are talking about, I have now to go a little bit more to the microphone, to the guys. I will use later on this microphone. Now, we are talking about digital projections. Everybody of you and me, we can make a Google search, and then you type in digital projections, either with let's say micro mirrors or with small LEDs, micro LEDs, and you find a lot of super pictures. And now the question for you all, this is now a quiz: what do those pictures have in common? I show you now 6 pictures from the various let's say presentations in the market. 6 pictures, some from car manufacturers, some from suppliers, and some from the tech suppliers. You see these 6 pictures. The question is, these 6 pictures, what do these 6 pictures have in common? Do you have an idea? Open question. Who thinks he knows what these pictures have in common?
Monocolor.
What?
One color.
One color, wrong. Next question, next answer. Yeah, okay. Better?
It's the outside view.
The outside view. The answer was right. Now, the fourth answer was the right one because they all have in common. The simple answer is Photoshop. Yeah, that's quite right. And this is one of our problems that we have today, that these digital projections for marketing purposes, for all other purposes, are a little bit overstressed. And if you now look, you can see, well, the Texas Instruments advertisement of DLP, well, perhaps not. And also the snowflake, which one of these cars is projecting on the road. You see, perhaps Photoshop helped a little bit. So, and this is exactly what we have today, that we have Photoshop, and we human beings are meanwhile in the situation that believe everything that is a picture is true. And now this is one of the problems, that there are many, many people who think, it can be distractive, look to this, it is not good, and therefore we have to forbid it. And this is the world of regulation where we think, we will not succeed with this. And therefore, the important thing that there was some research on distraction. So the research on distraction, first of the TU Darmstadt, was an eye mark system, which was done. There was a car driving, and you looked to this region of interest where there were some projections and the car was passing by. And the next is difficult to see. That is the eye mark evaluation. Where did these test persons, in total I think it were 80 persons, where did they look in the investigations of the TU Darmstadt with and without snowflake? And if you look to these colored pictures, not a big difference. Okay, next investigations was the Leibniz University in Hanover. They did quasi the same thing for one of the GTB sessions. They made also an investigations with an eye mark system, and they had different targets. Do the people look to the exterior mirror? Do the people look to the interior mirror? Do they look to the interior dashboard? Do they look on their own lane? Do they look on this projection area? Where do they look? And these are the results. Well, you see, a lot of people look to their own lane, which is very good. And only a few people don't look to their lane. And the important thing is, you see, this region of interest in the TU Darmstadt University was never touched from any view. And the interesting thing is that the University of Leibniz found that with static projections, 0.7% of the time the people look to the projection. Now the question is, are they blind? Why don't they look to the projections? Why don't they feel distracted? Why is it so different to Photoshop? And now this, what we did in an investigation. Now we made in our light tunnel in Audi, we made an investigation with this setup. We made a grid in our light tunnel where we had the symbol projection with a car. The green car was the projection. We had about in 25 meters or 24 meters the projection. And this is what a picture what you saw. And all the left part of this was split into 1 by 1 square meter positions where we placed test persons and said, can you read the letter? It was 900 square meter of position where we put the test persons. Here you see one picture. And these test persons had the task, you have to read in 5 seconds either this letter combination, it's 41OPW, or this letter combination LAME4, or this letter combination AE23P. You will see in all the other following pictures AE23P, for example. They had the task to read it in 5 seconds. It were 17 test persons, and the viewing angle from the car perspective, car driver's perspective, was about 0.43 degree, like a traffic sign. That is the symbol size that we projected on the road in 25 meters. And then we made some interesting luminance measurement. For example, we had a luminance camera here, which was looking to this AE23P, and this luminance camera made then this investigation. You see, we have about 2.5 candela per square meter for the AE23P. Above there is nothing, and in the front we have the foreground illumination, like we have seen in the lectures before, around 1 to 2 candela per square meter. Now this is what we did with our investigation. We could, with the luminance camera, also look about the contrast. What can you do if you write such an AE23P letter? And you see here that the contrast is 2 candela in the maximum, and the base is a little bit decay. We have about 1.5 candela. So it's a contrast of about 1 to 2. It's not much, but it's standard. So this is the message. We did nothing super scientific, it was more the reality. And with this, then we were able to also to investigate this AE233 from the car driver perspective, and we reached about 2 to 1.6, 2.1, 2.5 candela per square meter for the luminance of the letter E. Now, from driver perspective, the crazy thing is, if you make an overhead picture, that means bird's eye view, if you look detailed, you can really see on the top here, this means AE23P. Unfortunately, this is the disaster of these digital projections. From each position, they look different. And from the bird's eye perspective, they are 4 meter long and 2.4 meter long and 4 meter wide. So that's incredibly big. And if you then make the luminance investigation, this is what we did here, you see that the E, if we look to the E, never has the luminance that we have here of 2.159 candela per square meter. From driver's perspective, the luminance from bird's eye perspective decays to 0.155. And because the photons are distributed over a longer area. And that's one of the basic reasons why the readability perhaps is different. So this is one of the things that we found, especially this factor. It's a big factor, you see, that's more of 10, about 14 of the luminance factor that changes from driver's perspective to the crazy position of a bird's eye perspective. And all other luminances from all other perspectives are between. Now what we did, we did a test, in this case 15 meters in front of the car, 6 meters away from the sign. Who of you is able to tell me what are the 5 letters combinations here? Nobody, 6 meters. Okay, we come a little closer. 5 meters, who is able to tell me what he reads here? Nobody. Okay, another 4 meters, perhaps you can do it now? No? Okay. 3 meters, now it should work. Hector, what do you see? You see now AE23P in 3 meters, lateral from the pictures. This is 2 meters, here you see it better, and this is 1 meter away, lateral from this picture, 15 meters in front of the car. As you have seen with your own experience, it's quasi not possible to see from 6 meters, from 5 meters, from 4 meters. And exactly this is what then we investigated with the test persons, that we said, okay, we find a red-green area. The green area is where all test persons could identify the letter combinations, and the red area where nobody were able to discover to read it. And you see it's rather small. For example, here you have 9, and here you have 0, and it was 5, 7, 8, and so on. What we did together is the investigations here in 15 meters ahead. So we had in 8 meters, 7, 6 meters, 0, 2, 3, 5, 8, 9 people were able to discover it. A little bit like you did. So now if we summarize this, you can make the average readability zone, building some statistics, and the average readability zone is exactly this area, which is yellow marked, where the average of the test persons were able to read. It's not very much. It's only about 80 square meters of this 900 that we covered. And you see, it's rather small. The interesting thing is here, you can make some statistics, or you can look to it. You see, this is from the front side. There are these 2 areas. So this was the front, and this is the other situation where the people were able to read. Now, looking to the statistics, it's also nice to see that if you come close, that means from here, the average standard deviation is only 1.2 meters. If you make 2 meters, it's 2.5 meters, standard deviation. It's 8.9, it's 12.1, and 14.7 meters standard deviation. That means you have an average, and plus minus 14 meters is the standard. So it's quasi very, very weak. So many people can't read. Now from this average calculation, I calculated an average readability time, because this is important. How long are the people anyhow have the chance to read something? Take over, that means you are passing, you are taking over. oncoming, we have an oncoming situation and a pedestrian who's standing right at the side and the car is passing by. So the average, the delta was, I calculated about 80 kilometers per hour, which is this speed you see in the, oops, sorry, going one back. You see here we have 5.55 meters per second, because if one car is overtaking the other with a delta of 20 kilometers per hour, then the average delta speed is 5.5 meters per second. If you then look to the 37.44 meters, that means in the overtaking situation, the chances for a driver that is overtaken is 6.7 seconds. The drama begins on oncoming, because you have two relative speeds of 80 kilometers. That means you have 44 meters per second. You have exactly 0.43 seconds to see something, feel distracted, and write a letter to the authorities. The pedestrian is standing still, 0, and the car who's passing by with 80, perhaps we can recalculate 60 kilometers per hour, but it's 1.2 seconds. Even a pedestrian sees a car passing by with any letter combination, any symbol, anything, 1.2 seconds to feel annoyed and get a call to the authorities. And you understand why at the beginning there was no eye mark visibility to these positions, because nobody could see it. It was too quick. And the area where you can see is very
엄청
limited.
싫어하겠는데?
This is the truth versus Photoshop. Now, this is the summary. Digital projections increase safety, as I have shown before, with lane keeping, steering frequency and angle, gas throttle position, anything like this. The best persons, what we have seen, do not look towards the projections. Why? Because they can't read. There's no chance. They have, the reading time slot is really too small, only for the overtaking. But if you are overtaking, we all which have a driving license know that when you are overtaking, you normally do not develop so many interests what is in front of your overtaking car. But you want to look, is there some oncoming traffic? Do I drive safe? Keep my lane? And so on. So this is the focus of the eye movement and also of the interest.
오버테이킹이
And
다뤄지는
last,
책임이다.
there is no time to feel distracted. Yeah? There is no time to feel distracted. And all those which now pop up and say, we have some concerns about distraction, I say, read this, read it. At the end you can repeat it. It's not true. The fears that we have, the concerns that we have are Photoshop, nothing else. So, there are only benefits for digital projections, and there is no chance for any annoyance or for any distraction. That is the summary of my presentation. I thank you very much and encourage you.